Hi, I'm Mr. Furlong, and you're watching The Scientific Method. The scientific method has been around for a very long time. It started back in ancient Greece with a philosopher named Aristotle who said that you need to have empirical data to back up scientific claims. Well, that scientific method was modernized back in 1620 by this guy, Sir Francis Bacon, who I believe is an ancestor of the actor Kevin Bacon. Anyways, Sir Francis Bacon had a set steps that scientists should follow when solving problems. Now, there are a variety of variations on the scientific method, and so I've looked at many of these different steps in a scientific method and found that they do have some basic common steps between them. And so that's what we're going to be taking a look at today. Starting with step one, making an observation. Good scientists are observers. You are going to be making observations, and quite a few of them this year. And from those observations, we need to develop a question. Why does this happen? What is going on here? From those questions, we can then continue on trying to hopefully find an answer. For instance, here we see Alfred Wegener. Now, Alfred Wegener was originally looking at a map of the world and noticed that the coast of Africa and the coast of South America seemed like they might fit together. So he came up with a question. Could they have been together at one time? So then we go on to our second step of the scientific method, and that is to form a hypothesis. Now, a hypothesis is simply an educated guess. We need to have somewhere to start in developing to find out the answer to this. So Wegener's hypothesis was by cutting out the continents, putting them together to show maybe at one time they were all together. Well, of course, that's just a guess. You need to have empirical evidence to back up that data. How do we get this evidence? The third step then is to test that hypothesis. So you have to develop some type of an experiment. We're going to be doing controlled experiments in this class for the most part, and we'll talk more about that in another video. But you need to collect data to help support or to refute your hypothesis. In the case of Wegener, he looked at things like fossil record, and he noticed that there were fossils of the same species of animals on different continents. Now, is that a coincidence? Or maybe he thought that these continents were together at one time, and that's why we find their fossils together, and that over time the continents had begun to spread. He also looked at the geology and noticed that there were some similar rock features on the different continents as well. So he collected his data, and then you put it together, and ultimately you're then going to either accept or reject your hypothesis based on the data that's collected. All right, so let's take a look at a few things here. Notice the wording that is used. We're going to either accept that hypothesis or we're going to reject it. What we're not saying is that our hypothesis was right or our hypothesis was wrong. What we simply are saying is that we have data to help support it. Or maybe we have data that doesn't support it. That doesn't mean that we're wrong. It just means that maybe we need to do more testing. Or if we accept our hypothesis, that doesn't prove that is correct. It just means that we have data that helps to support that idea. A theory is simply a very well-tested hypothesis. It might have all kinds of data to help support it, but yet it hasn't been proven yet. And in the realm of biology, we deal a lot with theories. We just talked about the theory of plate tectonics, the theory of evolution by means of natural selection. We can't go from a theory which is unproven to a law which ultimately then becomes a proven theory. In the realm of physics, chemistry, they have a lot of laws. The law of gravity, the law of conservation of mass, right? But we still deal a lot with theories. But let me just make sure that you understand that a theory and a hypothesis are two different things. Right? I have heard over and over again people think that a theory and a hypothesis are the same. They're not. Hello. Do you hear me on this? A theory is a well-tested hypothesis. It has data to back it up. A hypothesis is just a guess. So we're going to take our guesses this year and we're going to help to support them. We probably ever won't get to the theory with our testing that we're going to be doing, but we're going to be collecting evidence to help to support that theory. And who knows, maybe someday what we do will become a law. So I want to thank you, and I can't wait to show you a great observation tomorrow.